Okay, so we're going to go ahead and simplify our radicals, and here's how we're going to go ahead and do it. So we're looking at the square root of 20, and I made a list of perfect squares here for you. So 20 falls right here on the list. So above that, which of these numbers go into 20? What's the biggest number? 4. Thank you. 4 times what? Okay. So I'm going to write the perfect square one first, and then take the square root of 4. What is the square root of 4? 2 root 5 is your answer. Done. That is simplified. Okay, let's try another one. Number 2, 98. So 98 falls here. Which of those numbers above that line are factors of 98?
36. 3 times 4.
Wow, really good? 98 is almost 100.
Nice. I mean, 4. I definitely grew 4.
Oh my goodness gracious. It's 49. Are we okay with that answer? Now what's the square root of 49? I will teach you if you aren't able to locate it, I'll help you locate it. Different method. Okay, square root of 33. So 33 falls here. Okay. Which of those numbers go into 33? Which of those numbers go into 33? I think it's going to 36.
4? Oh, wait.
None of them.
I told you. One does.
Exactly. But don't tell me that 9 goes into it if you're having trouble. Okay, well 3 does go into it, but 3 is not a perfect square. So we don't have any perfect squares on this one, therefore we can't do anything. This is our simplified answer. None. Okay, number 4. Number 4, this time I have a constant in front. Well, I don't see an operation using a constant in the radical, so what operation do you assume? Multiplication. Okay, so now let's focus on the 27. The 27 falls right there. So what number goes into 27? 9. Okay, 9 this time, right? 9 times 3. Okay, what's the square root of 9? So we're going to pull out that 3 and leave in the other 3. And now we need to reduce. Okay, number 5. I'm going to give you a minute to do this by yourself. You know how to do the fractions. You're going to do the square root of the top and do the square root of the bottom. Etc. As you're taking the squares, like you're not taking out of the squares. You can see it better if you separated them first. Okay, so what's down the denominator? The denominator is square root of not doing what is square root of 3. Good question. Okay. And how about 125? 25 times what? So what's the square root of 25? So 5 comes out and 5 stays in. Okay, now if you look at your fraction here, the 5/3, would that reduce? No. Alright. Number 6, again, fraction. Listen carefully to this. Normally when we tell you, however, at this point I'm looking at the denominator, and you know the square root of 144. So I think we should just take it. Now, later on I'm going to teach you what to do with the denominator, and you cannot take it. Like if you're doing something like that. So all your homework tonight, you should be able to do the denominator. Alright? So normally again I would just do that. Reduce. Then that's your hold on. Okay, so again, we have opposite, the square root of 84, and what's the square root of 144? Okay, so 84 falls here. 48. 4. 6. You guys are being a little bit silly right now, but I need you to really, these are little things that we can do fun. Okay, so think like tonight. Here with the square root of 4. So we get 2 roots, 21, all over 12. Now look at that fraction that's doing 12. Now can that reduce into a 1 and a 6? And it's a negative. A negative square root of 21 all over 6. Alright, we're going to start to throw some variables in there along with the number. So let's focus on the number first, 24. 24 is what times what? 4 times this? What's the square root of 4? Okay, so 2 comes out in the space, and the 6 stays in. Pop up to 24 so you know you're going to do it. Times 7. So last night, you did problems where it was like the square root of n to the 10th. What would you do? You would divide, because there was an index of 2 right there, right? And you get m to the 6th. Okay. There's no difference tonight, except that we're going to have a remainder. And the remainder is going to stay on the inside. Okay, so we're still going to divide by 2. So 7 divided by 2 is 17. And 2 goes into 7 how many times? 3 is a remainder of 1. That's number 4. Goes in 3 times is a remainder of 1. And that is it. Do you need the 1 there as your exponent? No, it doesn't hurt. No, doesn't. Oh, this one's number 8. So then he told you to do better than you split them up. 23y cubed and 4x to 6. So again, you know that denominator. So let's go ahead and turn it up. Absolute value bars. Okay, let's focus on the numerator now. Do you notice where you're 23? And it's 5. So therefore, you can stay inside. Can't touch it. However, y cubed. Okay, cube goes into 3 how many times? Once, with a remainder of 1. So they'll divide me just if you have a remainder, just stick it back in 5. Alright, same concept. Number 9. This time we're going to have the cube roots. So you need to think of all the cubes that we have. So right here, 8. 8 times what? 8 times 3. Now, get in the mindset you're doing cube root. It's the cube root of 8. 2. Make sure you keep it the cube root of 3. Good. Same concept. We're going to go on to a fourth. Fourth root. Okay, we don't have fourth roots listed, but 48 isn't that big of a number. And we don't generally do one. Don't worry about one. Let's go on to 2 to the fourth. What are the 8 to the fourth? 16. How does 3 to the fourth? 8 to the fourth. That's already 2 5. Is 16 going to 48? 16 and 3. Now, make sure you're in the mindset you're going to fourth root. What's the fourth root? 2. 2. Fourth root of 3. Okay, number 11 is on your own. It's the fifth root of 96. Go. Fifth root of 96. Fifth root of 96. Okay, what's the fifth root that goes into 36? Or 96. 32 times what? What is the fifth root of 36? Alright, continuing on, and I have actually a little bit more that I want to chat about. Because something the factors there you don't see them, and you all see them out. Alright, so, fifth root of 5? No, so it's going to say the fifth root of 5. Fifth root of 32? Alright, so what was the one that was hard to see? Was it the 98? Oh, yeah, okay. So alternate method. If you are struggling to find that factor, what I want you to do is find factorization. But I want you to do it in a certain order. So let's start with the 98. I want you to divide by the lowest prime possible. 2. Okay? And over to 49, maybe you recognize that it's 49. Divide by the next highest prime possible, not 3, not 5, 7. Okay? And then drop down to 7 again. So you know 2 times 7 times 7. The square roots, you are looking for 2 things together, and out comes 1. So 7 root 2. So 7 times 7 is 40. So the square roots, you look for 2 things together. For cube roots, you look for 3 things together. Fourth roots, 4. Okay, let's do another one here. Let's do 48. The square root of 48. What's the lowest that you can divide by? 2 to get to 24. Divide by 2 again, gets you 12. Divide by 2 again, gets you 6. Divide by 2 again, gets you 3. Okay. So this time, I see 2 sets of 2. So out comes 1, 2, out comes another 2. It'll be 2 times 2, 3, 3. Can you also see the number 16? Good thinking. Okay, let's go with 360. 360 is a full one. It's just a huge 360. Wow, it's a full circle inside. Oh, okay, Ruth. Scary things are time factorization. 360 divided by 2. 20 half 10. Can you divide by 2 again? 90. Can you divide by 2 again? Can you divide by 2 again? No. Start with those. Oh, 3. Okay. 9. Can you divide by 3 again? 20. What is 45 divided by 3? 18. That's not okay. Okay, I don't think it was right. Okay. This time we're looking at a cube root. So, do you know what the 3 is? The 2's. Okay. Only one of them will come out. Everything else will stay inside. 40. So hopefully that alternate method will help you get stuff tonight. But we've been going over and over all those exponents so that you are all set to go. Okay, your homework this evening is going to be in section 8.2. This is 48 to 78 even, and 88 and 89. Alright, so let's go ahead and get this started. I'll come up with the cutting them.